Mr. Mesa back here with you, and now we're on part 2 of integral test and P-series. So I said in the last video that those last 3 examples were going to be important. Why were they important? Well, those are a specific type of series called a P-series. Now, P-series is a series that basically has 1 over n to the p, and p being any power, but there's a neat little test that works for P-series. So if you have a series in that form, 1 over n to the p, if the p is greater than 1, then the P-series is going to converge. If the p is less than or equal to 1 but greater than 0, that series is going to diverge. So really quickly, taking a look at those last examples, if you remember from the last video, notice I had 1 over n. Here, the p was equal to 1. What did it do? It diverged. Here, the p was equal to 1/2. Well, that's not bigger than 1, and look at what happened. It diverged. Here, the p was 2. And, of course, it converged, just like we thought it would with a P-series test. So, there is a specific type of P-series called a harmonic series. And a harmonic series, a P-series that the p is equal to 1. So the example that I just did before in the last video, the first one here, 1 over n, that was called a harmonic series. It's a special kind of series. It does come up often, I guess. So if you can notice that it's a harmonic series, you know what? Later on, when we do another test, you'll see why knowing these P-series and a harmonic series is going to be very, very helpful, okay? So the P-series test is pretty easy. You just got to see if the P is bigger than 1. All right, so let's take a look at some examples here. We'll use a P-series test to determine if these series converge or diverge, all right? So what's the most important thing here is we got to notice that this is, in fact, a P-series. So let's go ahead and convert this to a sigma notation. I know you guys love converting to sigma notation. It's like your favorite thing in the world, right? So what's going on here? We've got 2 root 2. Whoa, what am I doing? I just spurdiddled. That's not really a word. I just kind of made it up right now. So what's going on here? We've got 2 root 2, 3 root 3, 4 root 4. It's probably better if I notice here that this is, if I guess I could say this. I can go, this is going to be 1 over n times root n, right? That's pretty easy to see. N root n. Well, let's go and simplify that a little bit more. N equals 1 to infinity. And let's change n to the square root of n to n to the 1/2. And then we add the exponents, and we get n to the 3/2. All right, so this is a P-series, and so P is equal to 3/2, which is greater than 1. So this series converges.
I found one TV show.
That's so funny. Did you guys hear that? So I said series, and the iPhone thought I said Siri. It told me something about Nash. Can you believe that? Okay, so this is going to converge. The series converges by the P-series test. Okay, let's try another one here. Zoom in. All right. Can we simplify this guy? Well, obviously we can, right? I wouldn't give it to you if we can't simplify it. So let's try to simplify this guy. We've got n cubed times n to the negative 11 thirds. Then we are going to simplify that guy by adding the exponents. So we're going to get 3, which is 9 thirds, 9 minus, it's going to be negative 2 thirds, right? So 1 over n to the 2 thirds, right? This is going to be n to the negative 2 thirds. All right, so what do we got here? We got n 1 over n to the 2/3. This is a p series where p is 2/3. Now 2/3 is less than 1. So this series diverges by the p, oh goodness, series. Come on, Siri. P series test. Oh, she did it again. Oh my goodness gracious. Guys, here is some advice for y'all. When you're doing a video about sequences and series, don't have an iPhone next to you because it will go off and think you're talking to it. Anyway, this was the P series test, and it's actually, I think, pretty simple. All right, we'll talk to you guys later. We'll see you guys on another day. See you guys later. Bye.